Hello and welcome to this video. Today we will discuss about logistic regression, what it means, why it belongs to regression family, and very important question is what it uses as a mathematical operation in the backend. So the agenda is very clear today. We will discuss what is this algo and what is the type of this algo. We will discuss why it is in regression family, even though it does a different operation. Why logistic regression as in binary classification is used, why it has this name, and what are the ways we can also overcome when it is not binary classification as a target value. Okay, we will also discuss today what is sigmoid function and how it really works at the backend. So let's start with the video, guys. First of all, guys, what is the type of this algorithm? So we talk about the classification that we have, the machine learning division that we have. We have two things: we have supervised learning and we have unsupervised learning. In that, the classification part comes into the supervised learning, and in this supervised learning, we have this logical regression. Okay, but it belongs to the regression family. So basically, it comes in the supervised part. It is a classification algorithm, but the name is logistic regression, and regression is attached to it. Okay? That is one thing that we will discuss in the coming time. The type of the algo is classification. That is what we need to remember. This is very one of the important point that we need to remember when you were discussing logistic regression, because by the name regression, people tend to think that it belongs to the regression family, which is a very rookie mistake. So let's move forward. So when we talk about regression or logistic regression, the very obvious question is why it has regression name in it. Okay. So guys, if you can notice that we have a proper line that is working here, a proper line is working just like the regression family. Okay. Just like regression, we have a curve here, which is basically an S curve, which can be termed as regression family because it uses a line. If you straighten it, it's a line only, which is curve form, and that processes the regression. Now, basically, logistic regression use a method, is a technique which belongs to the regression family. So, at the root and backbone, it's a regression method, but it used as a classification method. Okay, so let's move forward. Logistic regression as a binary classification. So first of all, guys, most of the people don't even know why we call it binary classification. What it does it mean? Okay, when we say binary, that means we have just two. Okay, so what is this two? Basically, guys, it means that in the target value, that is the value that you want to find as a target, in your target column, you only have two classes. It can be A and B, yes or true, 1 and 0, true or false, anything. But it has just two classes. When you have just two classes, it is called a binary classification. We are only going to give result in two parts. That can be 0 or 1. Okay. No third class will come into the play. Okay. So it has only two classes at the end. One important question, sometimes it is also used to into the classification more than two. That is one to the rest, which is a very advanced and different topic. But giving you an idea, suppose if you have one and two and three class, so what it does, it take these two classes as a single family. Okay, it take this class as a single family, and now it do the classification on these two. Once it is done with it, it take do the classification again on these two. Okay, that is how it overcome the issue of when we have more than one family or one target value or two target value at the end. Next is what is sigmoid function. Okay, sigmoid function has a great explanation, and if we actually talk about sigmoid function, it is not just machine learning part, it also belongs to deep learning. When we work in deep learning, sigmoid function is one of the most important attribution function that we have, which we use in the output layer. Now again, it's not about deep learning or machine learning. What specifically sigmoid function really do? Okay, sigmoid function is the core mathematical formula that we use at the backend in logistic regression. The formula states that 1 by 1 plus e to the minus x power is basically going to give us the result either in 0 and 1. Now, how it really works and how it really decides that it will be 0 or 1. So, it's very straightforward logic is there that we have this zero point 0.5 and the p value is calculated. If the p value is simply equals to or you can say greater than this, okay, you may say if it is greater than this zero point 0.5, That means it will be 1. Okay, if p value gets greater than this, it will be 1. If it is equals to 5 or below that, that's a 0 for you. Okay, so either it will classify in 0 or 1 for you. That's how Sigmoid function work at the backend. So let's see how the coding part really works, how the logic really works on this in the coming slides. Now in the given code, the aim is very clear. We want to discuss how the logic regression is getting implementing on the data set. Now we are just inputting the algorithms, or you can say the main, not algorithms, but the main library that we want to use. That is Pandas, Seaborn, and Matplotlib. And guys, we will not discuss any of it. Basically, I will simply skip the to the point where we have all the numerical values. So when I actually import this, you have a data set and you work on that. Data set is straightforward. We have the titanic data set, which is very famous. It has just these columns: class ID, survive column, and the P class, name, sex, each sibling, and all these values. The main target value here is survive column, which has the binary output that is 0 and 1. And that is why I have picked this data. What I will do, guys, I will simply move forward and drop the columns which are not really important. And I will only work on data where it is really going to make sense. Where we have this value which are completely, let me say this part, which is completely numerical. Okay, we have a data which is completely numerical, and the survive column is our target value here, where we have 0 or 1. Here's what I want to do. I want to implement the logistic regression on this particular data set. How I achieve that part, guys? If I just move forward and show you the column, we have these columns in the data set, and survive column is my target value. Obviously, guys, when you're working on a data set, we always want to separate the independent column and the dependent column, and that is the fashion we give the input to our machine learning model. I'm assuming you're already aware with cleaning the data, which I have skipped completely, and you are already aware how the machine learning model really works. I'm only going to talk about logistic regression and how it really gets fit into the algorithm and modeling, and do not want to kill your time on plotting and pandas part and numpy part, because I am assuming those basic stuff you already know about. Okay. Now, guys, moving forward, we are from sklearn dot model selection. We are importing train test split because we want to split the data for a validation part and the main training part. Now, what I did, guys, I simply remove this survive column. You can see simply pick the survive column and put it in the new variable. That's my target. Now, this target will be given as an input as a dependent value in the training part. Now, guys, what I will do next is I'm going to drop the survive column for my data set. So I have only independent column in the data and the target value. What I did next is, guys, I simply move forward. So let me run these cells too. Okay. After dropping these two, I'm printing the hat. This is my data set that I'm having. No more survive column is there. Next, I simply move forward and simply run this. I have splitted the data, guys. I have given X and target here. Split it is done with the 30 ratio. Random seed is given 0. I'm getting four variables: X train, X target, and X target train, X test, and target test. Running all the four values to show you the output. And here we go. So guys, now what we need to do, we want to implement the machine learning algorithm. To that, I will simply import logistic regression. This is my logistic regression algorithm. I've created the variable here. Then I have fitted my data. Guys, again, the independent data, the 70% part which I have kept for training, that part I'm fitting here. So I'm fitting my X train and target train to my data, to my model. This is the part where the learning process goes on. Now, logistic regression will learn this data. Guys, now there are n number of parameters that you could have been given. You can use as a parameter and give it. Okay, but I'm not going to use any of the parameter, as I'm going to use all the default settings. In case you see a maximum iteration error, you may increase the iteration error if you're using it in a for loop. So if you use in an iterator, you can say for loop, while loop, you might have to increase this value as per the row. We have 891 rows, so I will simply use 891, or we can directly make it 1000. That is also okay. Okay, guys, moving forward, what I did next is I fit it, did the training is done. Now I'm checking the target shape just for the casual check here, and I am testing the data. Now, guys, I will give lr.predict test my data, it comes in the result, and next is the accuracy check. I use sklearn.metric, import the accuracy score, and implement my accuracy here. Okay, now I'm getting a accuracy of 80% in my model by training in this way. So logistic regression is a very powerful algorithm which can give you great result, and you can also compare these model, and hopefully I will also make a video where I will compare all the algos and see how the algos are performing on this very data. Okay, this is all for logistic regression. I hope you like the video, and I hope it was fruitful to understand the concept of logistic regression. That is all for the video, guys. Thanks for watching.